Okay, so you're writing a thesis. Maybe it's an undergraduate thesis, maybe it's a master's thesis, maybe it's even a PhD, and you've decided to do an empirical paper. So what should you use? What software should you use? Well, here I want to tell you, don't use Excel. Don't use Excel for anything. Now, I love Excel. It's a wonderful program. I use it all the time. But for empirical work, you should not use it. You should not touch it. You should not divide two numbers with Excel. You should just get your data into a program that can do scripting and never touch Excel. So there. You've got the punchline. You're done. If you want to know why, stick around. Okay, so why am I so against Excel for doing your empirical work? There's 4 reasons why this is. And I'm going to start with the least important and go to the most important. But any one of these is good reason not to use Excel for your empirical work. What you want to do is you want to get a program where you can script it so that you can see the steps that your empirical work is taking. So I'll have another video about that. But for Excel, why you should avoid Excel at all costs is, first of all, it is super easy to make mistakes. When you have a function, when you have a calculation in Excel, you're doing it item by item by item. And anywhere in those items, you can make a mistake. You can make a copy mistake, you can make a formula mistake. It's super easy to do that. Which is a real problem. For example, a couple of very famous senior macroeconomists had a high-profile paper which they did in Excel, and they had mistakenly not had all the data in their formula. So they left out some of the countries just by mistake, and that totally changed the results of the paper. If you were using a program designed for data analysis, you would be able to catch that error. But when you're using Excel, you can't. It's easy to make that kind of errors. And secondly, it's very hard to tell when you did make an error. If you make an error, you can have all your formulas right except for 1 or 2 rows, and then nothing. You'll never find that error. Now, there's a few debugging functions in Excel, but they are very anemic. They are not, they're better than nothing. But the fact of the matter is, in real life, you will never notice that you made an error. There's no way to check whether you made an error or not. And since it's easy to get errors into the program, you see errors into your formula, and then you don't even see them once they're there, that's a real problem. And it's very hard to know even what you've done, right? Because you can look at, let's suppose, for example, that you had, GDP, and you wanted to deflate it to get real GDP. Fine. You take GDP, divide it by the GDP deflator, you're good to go, right? No problem. It's easy formula. You enter in you have a column with all your GDP, you got a column with your GDP deflator, and then you make a new column that's 1 divided by the other, you're good to go, right? Easy. And it's very easy to do. But in fact, there's no way for you to tell whether you've done it for all the rows, or if you've done it correctly for all the rows, or if you decide to change to a different deflator or a different set of data, like the updated deflator or whatever. It's no way to tell whether you've done that for all the rows. It's very easy to miss something, and once you've done that, you don't even know. And so when you come back to this, right, so you're going to be entering your data, you're going to be working with your data, and then 2 months in, you're going to wonder, what exactly did I do? Well, you can go back to your worksheet, no problem. You go back to your worksheet and you say, okay, we got column C, got C2 divided by D4, and then you have to figure out what all those mean. It's really hard to do that. Not only are you not sure that it's the same for each and every row, but you're not sure exactly what that is. You have to decipher it, right? Which is a problem because you're going to be making lots of decisions. You're going to be doing lots of different things with the data. You're going to be manipulating in various ways. And then you can't hold all that in your head. And even if you're super skilled at holding stuff in your head, and you can, that's using up space in your brain that's better used to think about your real problem, right? So You come back, and you come back in a couple months, you say, what exactly did I do? You have to decipher that. You have to decode it, and it's very difficult. Whereas if you had a script program that said, take GDP, divide it by the GDP deflator, and you have the variables named nicely, you can read that in 2 seconds, and you know what you did. Whereas otherwise, you're trying to decipher this worksheet, which is problematic later on because you will forget what you've done, and you want to be able to check, right? And that helps you with debugging too, right? Because if you have it all written out like that in a script, then as you're skimming through it, you can see GDP divided by the consumer price index, and you can say, hold it, that's wrong, right? It's supposed to be the GDP deflator. Why did I divide it by the consumer price index? That's just an error. We all make mistakes. You made a mistake, but if it's there on the paper and you can see the formula, you'll notice the mistake and it's an easy fix. But if it's in the worksheet in Excel where you did that, then you'll see column C divided by column D. Yeah, that sounds fine, right? It's dividing. You'll never notice that you divided it by the wrong price index. And then you won't even catch that error. You won't even notice that it's there. And lastly, the most important reason, and any of these would be perfectly good reasons not to use Excel. Like just don't.
Open your eyes, people. Hunger, racism, small businesses. It's like, maybe don't.
But the one really big one is that somewhere along the line, you may want to update your data. Maybe a new set of data comes out. Maybe this is a great thesis, and your advisor says, look, I think this can be turned into something publishable. And so if you do a bit more work, you can get something publishable. So then, 6 months down the line, you say, yeah, I'd like a publication out of this. That would be great. And so you get to work on it. But now there's updated data that's come out. Well, if you've done it in Excel and you've refactored all your data in Excel and you've massaged it and you've dealt with the missing numbers and you've done all that in Excel, you've got to start from scratch when the new data comes out. Right? Maybe new data comes out. Maybe someone says that instead of the CPI, you should use the producer price index or whatever. If you've massaged all your data in Excel, you've got to start from scratch. So first of all, you've got to remember what the heck you did. Or, I don't know, it was ages ago, right? How did I deflate that thing and exactly what steps did I take? And how did I deal with the missing data? How did I deal with the fact that this was only available for so many years, but then I switched over to something else? All that stuff you have to remember and reconstruct. Basically, you're starting from scratch when new data comes out. But if you use a package program and you have a script, then you just say, okay, new data, run it all. So you shouldn't touch Excel. You should not, because you can't replicate it, you can't debug it. It's very easy to get errors into it, and it's very hard to even know what you did. So you have to hold all that in your brain. So what you should do is you'll get your data. Very often it will be in an Excel format or in a comma separated value format, which is sort of Excel adjacent. Load it into Excel. See that it's there, scroll through it, close it, never touch it again, right? What you want to do is you want to load it into a real program, whatever one you want, R, SPSS, MATLAB, Mathematica, whatever it is that floats your boat. We'll have a video about that as well, but whichever one you use, load it into that program from Excel, right? Or from whatever format they give it, very often Excel. So then you load it directly from Excel without touching anything in Excel. You do all the massaging of the data in that package program with a script. And then you have that script that tells you exactly what you did. You don't have to hold it in your brain. You can debug it. You can see exactly what you did on paper. And so 4 months down the line, it's easy to go back to that stuff.